Hello everyone, this is a very simple machine learning project on linear regression. So the objective of this project is we have here the student data in which we have the study hours, how many hours a student is studying. So on the basis of the studying hours, how much marks he will get. We have to predict it. And in this data set you can see that here this fourth row, so this is like there is no data, that is missing value, it has some missing value, so we will do some data pre-processing even. Here you can see it is also like no hours are given. So our main objective is according to the study hours how much marks a student got. And before and after that what we will do, we will make an like an Flask app.py, and then we will be doing one thing, that using HTML. So for front end, very simple, very basic, everything is very basic in this like a project, so we will do that. So I did it on Jupyter notebook. So this was the data set. It has a very less number of like data, that is 200. So and you can see here that so this is the Jupyter notebook. So see the Jupyter notebook here, I will show it here. Okay, so I imported the basic libraries here, NumPy, Pandas, and Matplotlib for like data visualization even here, and I loaded the file here. So you see this is the studentinfo.csv. I loaded it with pd.read_csv. So now I will like run it, and you see. So wait. Let it like connect to the kernel first. Okay, so yes, wait, yes. Okay, so it is saying that PD is not defined, so we have to run the first cell event first, and you got it now. And then we will run this again. We will load the file here. See, so the data set have, you can see the data set here, isn't it? And we wrote pd dot output is no file, studentinfo.csv, no file or directory. So here you see, like I am doing it. So I will go with this Python here. Let it like connect to the kernel first. So this is Jupyter notebook now here. And what I am going to do next is, so we have imported NumPy, Pandas, and Matplotlib. Then we will load the file here. So you can see if I see the first 5 rows here. So study hours, we have a NA and not a number like null value here, so we will by like pre-process it. We will see that. And the last 5 data you can see here with df.tail, and that is like these are there. Okay, and now so we will see the shape. So there are only 2 columns. I told you this is a very basic project, very much basic in linear regression. So I took only like for the input variable, another is output variable. Okay, so you see, so it looks like there are 200 like rows and we have 2 columns. Okay, now so we will get some like we will visualize it, we will see some stats here, and that is like for if you write df.info, so you see that in study hour column we have 195 data only, but in student marks we have that column where 200 rows are there, isn't it? So we will see it more. And if I will like description, we will see, so df.describe, we can find the count, you can see count of both the columns, the mean, standard deviation, the minimum value, 25% like first quartile, second quartile, and the third quartile here, which we call it as the mean even of the data set, and the maximum value is also given here. Okay, and now we will go ahead and we will plot it. So a simple scatter plot I am drawing, and you will see that linear regression which follows the equation of a line, isn't it, that y is equal to mx plus c. So you see here like in the x level we have like study hours, and in the y level we have the marks obtained by the students. And when I show it, when I plot this, you can see that all the like data points are like scattered in a way, and you can see that there is a line. We will find the best fit line event, so we will go through that. But first what we have to do, we have to remove, or like we have to handle the null values, so what are the null values? You see here that it is df dot is null, so it will tell us here that it will give us true or false. So the first column is like not having null values, so that is giving false and false. But you see in the third row we have here true, it means that this is a null value, so we have to handle it. And now how to handle this? So we can impute like mean, median, mode into this. So we will first, you can here see, but in the description we have already like seen in the info of this data set that what how many null values are here. So study hours has 5 null values. Whenever you will read df dot is null dot sum, okay, and how many student marks are having null values? So there are nothing, 0. Okay, so you first see here very clearly, you see here that if we have the mean of the study hour column, that is 6.995949, so what we will do, we can impute this value to every like wherever like we have an empty row. Okay, so in the study hours, and the mean of the student mark, that is 77.933759750, but we have to like we have null values in the study hour column. So what we will do here, we will fill an a, we will use that fill an a here. So we will create another data frame. So I am not like I am keeping the original data frame which was our df, so that is as it is, and we are going to like df2 here. And here what I filled, wherever there is like NA, wherever there is like null values, you put df dot mean, the mean of the whole column. And you see I did it. So yes, there is no error. But when you run the like this data frame, you can see on the third value it is 6.99. so the mean was, you see the mean is here, this is like 6.99. so you got it here even at the like second the third row. Why? So we have imputed the mean value here wherever there was null values. And if I go ahead now, and if I will see that what is the sum of this, so that is like report have no any null value. Okay, very great. Now we will split the data set, and splitting the data set, only 2 columns are there, so make one column, we drop the another column student marks, so it will become like for the study hours. So x is study hours and y is now student marks. Okay, because we drop like study hours here, so this y is the student marks. So if you want to see, here one thing, the shape of both the like after splitting the data set into x and y, so you will see here that x is also 200 rows and one column, shape of y is also 200 rows, one column. Now we will, from sklearn, what we will do, we will import train test split, and we will split the data set into like train data and test data. So x train, y train, x train, y train, x test, y test, and we will use this function here like train test split, and we put both the x and y here, and the test data, so we will take that is like we will train this data with 80% of the data set. Okay, and so 0.2 I took, that is 20% of test size. Now if you want to see the the shape of the x train, y train, x test, y set, you can see here, but let me first run this. Why are you doing like this, huh? Okay, so it has also run now, isn't it? Now I will go with the next one, and we will print the see the shape. You see here 80% out of 80% of 200 is, that is 160, and 40 is like for x test. So this is the train data, this is the like what, tell me. Yes, so that is the test data here. Now we will select a model here. You know that we are going to use regression, linear regression here. So linear regression, we should follow this equation, isn't it? Y is equal to mx plus c, where m is the slope and c is the intercept of that. Like whenever if I draw, so if you can see that I'm drawing here, so here it is what will happen. So if this is our data set here, like this is the line of baseline of fit here, so what will happen here, what will happen, so this is our intercept here, you can see, and this is the slope, the y over x, that is the slope. This is the basic mathematics, isn't it? So what I was saying here, so we will be importing first linear regression from sklearn.linear model. We import linear regression. The linear regression is, we have initialize the model, and now we will fit the train data into it. So LR is equal to linear regression, and I am fitting the data set into this model. So we will put the train data, x train, y train here. So now you can see that model has been created. We have trained it, and out of this, if you see here one thing, that what is the coefficient of this line, the line created, what is the coefficient, which is actually the slope, and what is the intercept. So you see LR dot COEF underscore coefficient. Okay, when you run it, you can see it, you got the coefficient, like value of m, you got 3.93, isn't it? And when you want to find the intercept, means y is equal to mx plus c, so this is 50.54, this is the value of the intercept. And when you calculate it, when you put it, and for example x is the number study hours, a student studied for 4 hours here, so we will put this formula, we will put the values of m and c in the formula. Y is equal to mx plus c, and we will get m multiplied by 4 plus c, and when I run it, you will see here that the student will get 66 marks approximately. Got it? Okay, similarly, when I want to predict this model, now very simple model, very simple. When I want to predict this, you see, so I can predict it, lr dot predict function I will use here. So you can see I will use predict here, and what I will put here, this force is that what is the input value, that is our what here, that is the study hours, 4 hours, and this 00 means what, that from the first row take the first element. Actually we have here only one row, so don't worry, it will be coming like this, you see. So you see 66.19, and here I was getting with this formula 66.16. So they both are exactly same, not exactly, they are approximately same. 66 marks the student will get if he studies for 4 hours. Okay, okay, very great. Now I will predict here. I will create a function predict with the test data. So ypred is equal to lr dot predict x test, and so whenever you see here, so you got it for all the test data. And now what I will do, I will do nothing. I will concatenate everything, this predict variable, and the study hours and the original marks what he got in the data set. So you see pd.dataframe np.c numpy.c and then an underscore here. So this is like concatenating. We are concatenating x test, y test and y print, and the columns are study hours, student marks and the original student marks original and the student marks what is like being predicted now by this model, okay, on the test data. So and we can do one more thing here, and that is what like the fine tuning of the model. So you see that how much is the score of the data, the accuracy score. So for finding the score, what we will do, we will check it on with the test data. So we will put lr.score. Lr is our linear regression model, x test, y test, and I run it. You see 95%. Very great. And if I will like plot it, you see I will plot two things for the train data and for test data. You see the plots now. So you can see here it's that like this is already there. It is linearly like they are already linearly scattered. And when I do the same thing with x train and the predicted train data, okay, so you see here you will get the line of best fit here on the test data actually, sorry. So plt dot scatter on the test data you can see, and this is the line of best fit. The line of best fit is given by that like as the predicted data for x-ray. And now what, so this is like, this is very simple, the very simple linear regression model and project actually. So what you will do, you now save the model. So for saving the model, what I did here, I imported joblib and then joblib.dump and the model name lr, and then whatever name you want to give to the pickle file it will form, that is students marks predicted.pkl. You can, so I am doing that, so a pkl will be formed, you can see here. But if you want to now like use this pickle file, so you will create a model is equal to joblib.load and like this. And here again I have like for 5 hours if the student is studying, how much he will get. Let's check it. Yeah, 70 marks. For 4 hours he was getting 66 marks. For 5 hours he will get 70.12 marks in his examination. Okay, now you have this pickle file. So what you do, I created here an app.py. So on Flask, so create an app Flask name and then give a root to it for like so you have to like load the model first, that is joblib.model, and the pickle file whatever you named it, that is like student marks predicted.pkl, and then give the root to the HTML file. So that is what rendered underscore template return, it will return index.html. So I created a basic HTML, you can see here also. So where is that? Yes, you see this is nothing but like I gave a title to this predict student marks, okay. And so you see here from action equal to submit, whenever you will submit the marks, it will like go, it will go and predict through the model app.py, okay. And then the button is like submit here and the value is predict. So why predict, you see here in app.py what we did here, that we created here a function submit, okay, and the method I gave here is post. So now what happened, so hours, you will put hours in that form, so that is whatever number of hours you put, and in prediction variable I put the model dot predict that hours and give the first right row from it. Then I send it to another HTML file, that is result.html, where that this prediction is equal to prediction, and then run it. So it will come to result.html, you can see here, and in the result you will see that yes, the prediction sorry, so the predicted marks based on the hours studied, the predicted marks are that prediction, okay. So what I will run it, I will show it that yes it is working or not. So go to app.py, or wait, let's start a terminal here. Okay, let it start. Yes. So you write nothing but here python dot y dot python app dot py. Okay. Then enter, and what you will see here, yes, you see this like link here. So click on this. So when you click, you will come to your browser, and you can see a very simple HTML, very simple. So that is predict student math study hours predict. So what I'm going to do, I will give here like a student is like studying for 7 hours. So how much marks he will get? So click predict, and you see it is saying based on the hours studied, the predict mark 77.99. Got it. But if a student, you can see click here predict again, and if you write here like a student is not like for 7 he was getting 77, for 8 hours let's predict how much he's getting. So he will get 81% marks, approximately 82. So this is the project. If you got it, if you liked it, let me know that. And so have a great day. Bye. Thank you.